Okay, boys and girls, I'm back with another Math Daily Review video. So this week, while we're out, you had 4 Math Daily Reviews. This is for Friday, but you don't have one for Friday, so this will be your notes page. And I did this with the class on Monday, but since some of you weren't there, I'm going to do a video on this. And also look out for videos that are coming up on number line fractions, as well as adding mixed numbers. So let's review subtraction. When you are subtracting, if the bigger number is on top, you subtract normally. And you always start from right to left. You start in the ones place and you move across. So 7 minus 6 is 1. But here I have all these zeros. So the strategy is you borrow or regroup from the first non-zero. That's a 1. That's in the 10,000s place. So I borrow a 10,000 and I regroup it to 10 thousands. But now I need hundreds. So I take one of those thousands, I have 9 left, and I add 10 hundreds to whatever I have here. And I need a 10. I need some 10s here. So now I'm going to regroup again. I take one of those hundreds and exchange it for 10 tens. Now I'm ready to subtract because all of my numbers on top are bigger than the numbers on the bottom. So now I subtract the tens. I have 10 minus 8. That's 2 tens. 900s minus 500s is 400s. And 9,000s minus 1,000 is 8,000. And I don't have any 10,000, so you drop that zero, doesn't come down. So my answer is 8,421. Okay, so review that strategy. Remember, regrouping when the bottom was too much on the floor, go next door and get 10 more. Okay, multiplying with zeros. So zeros are friendly. We like that. We like zeros. So when you have this zero here, you can just bring it down and cross it out. And then we multiply using the standard algorithm. 6 times 3 is 18. So the 8 will go in the tens place, and the 1 will go above, and we circle it. And we're going to add it later on. Then we multiply 6 times 9, which is 54, plus 1 is 55. The other strategy that you can use is use the box method or the area model. So I break up 93 into 90 and 3. The 60 I don't have to break up because it ends in a 0. So I'm going to have 2 parts here. 90 times 60 and 3 times 60. 90 times 60, 3 times 60. Well, this answer is going to have 2 zeros in them. So I put them down. 9 times 6 is 54. So that's 5,400. And this answer is going to have 1 zero because there's 1 zero here. And then 3 times 6 is 18. So that's 180. And if I add these 2 parts, I'll get that answer. So you have 2 strategies there you can use. Okay, addition. And when it's written horizontally or sideways, you want to write your numbers vertically. We use the standard algorithm in addition. Many of you are comfortable with that, but let's do a quick review. I add from right to left, starting with the ones. 6 and 3 is 9. 9 plus 1 is 10. So when that happens, I place a 0 in the tens place, but the 1 above the hundreds place because it's regrouped. And now I have 300s and 8,000s. So that's my answer right there. Okay, so here I have to find the missing number, the missing fraction number. Remember, fractions are numbers also. So here you're adding to 1. So I like to use a model. And this fraction tells me that I have to break this up into 3 parts because this fraction is 1/3, which means I have 3 parts that make one whole. And 1/3 will get shaded in because I know I have that. I'm looking for the missing part. Well, I have 1/3 here and 1/3 here. So when I add these 2 parts, that's 2/3. That's my answer. 2/3 plus 1/3 equals 1 whole. So that's the strategy you want to use for that. Okay, here we're comparing fractions using less than, greater than, or equal to. Now, the numbers will speak to you. If both fractions or both numbers have the same numerator, then I compare the denominators. Well, halves, these are called halves, are bigger than sevenths. How do I know that? Well, just think about a piece of cake. If I cut a piece of cake in half, that piece is going to be bigger than if I cut that same cake into 7 parts. So 1/7 would be less than 1/2. Now all the fractions will look different. So you have to remember, let the numbers speak to you. Read the fractions carefully, look at how they're set up. If you have a situation where the numerators are the same, then you just compare the denominators. Okay, this is new this week. We have fractions on the number line, and they want you to pick the letter that best shows 5/8. Well, I know 1/2 would be 4/8. So A is 4/8. Well, 5/8 is 1 more eighth. So if I look at C and D, they're too far away. So B is the best choice. You also can think of it like this. If you cut your line, you can actually make eighths. So I have 1, 2, 3, 4, 5, 6, 7, 8. You can cut your line into 8 equal parts. That's another way to do it also. All right, number 7, which option shows the fractions ordered from least to greatest? So that's from smallest to biggest. Well, all of the denominators have 7. So I just look at the numerators. And I pick this. I'll go from small to big. Oh, that's no good. It's got to go in order. This is going from bigger to smaller, so that's no good. This is out of order also. So this is the best choice. 2 is less than 4, and 4 is less than 5. And the sevenths are all the same, so you just look at the numerators. Okay, and all the fractions for this page are like that, except that the denominators might be 6 or 8, but they're all going to have the same denominators. All right, so the word problem. One word problem this week. A new video game console needs 9 computer chips. If a machine can create 914 computer chips a day, how many video game consoles can be created in a day? So, new games console needs 9 computer chips. So that's the group. If a machine can create 914 computer chips a day, how many consoles can be created in a day? So this is division. I'm dividing up the 914 chips into groups of 9. Every group of 9 is 1 console. That's how you have to think about it. So when you have 9 computer chips, that's 1 console. If you had 18 computer chips, that would be 2 consoles. We have 914 computer chips. So that's division. We're going to use long division or the standard algorithm for division. Remember, you have Big 7, pots of gold. Check out those videos on my YouTube page if you forgot. So DMSB, divide, multiply, subtract, bring down. We divide 9 into 9. Well, 9 is 1. Then we multiply. 9 times 1 is 9. Then we subtract. 9 minus 9 is 0. And then we bring down the 1. and do it all over again. 9 can't go into 1, so that's 0 times. And we have to remember to place the 0 here. We can't leave this blank. So you have 3 places here. If that happens, we bring down the 4. We skip the other steps. And then we divide all over again. 9 into 14. Well, 9 can only go into 14 one time. And then we multiply. 1 times 9 is 9. 14 minus 9 is 5. That's our leftovers. But our answer isn't 101 remainder 5 because that's not answering the question. How many game consoles? Well, the 5 extra chips, you can't make a game console from it. So we drop that out. So the answer is 101. So when you read division problems, make sure you know how to interpret the remainders. And then the last problem, use a visual model to solve 3 1/3 plus 2 1/3. So the strategy that I've taught is to first add the whole numbers. So the big numbers are 3 and 2. So that's 3 whole circles. Because remember, that 3 is not a third, it's 3 wholes. Plus 2 more whole circles. So that's 5 so far. And then we add the fraction numbers. Remember, these are numbers too. 1/3 plus 1/3. All this shade in 1/3. Plus another 1/3. Well, that's 2/3. 2 out of 3. So my answer is 5 wholes plus the 2/3. Let me write it like this. Okay. Good luck with these. These math sheets you have for the week. And check out this video for support. All right, boys and girls. See you soon.